Welcome. I'm very pleased to have you here, and welcome to my talk about, demystifying annotations, exploring and explaining the magic. To be honest, there's no magic. It's just code. And I frequently see people who, they back off because the annotation, it's kind of scary. There's this grimy, dark reflection API. What does it do? So I'll try to answer that today. All right, my name is Tomasz Borek. If you want the slides, slides for this presentation, send me an email with the feedback, what you would like to see in this presentation, things that I need to keep, things that I need to improve. Once you do, you'll get the access to slides. Now, without further ado, I have a blog, I have a Twitter, I have, my own company, Daffy, and I'm frequently, I worked for Semantis. So Semantis is here, as pretty much the thing that got me started. Now, the other thing I would like to tell you here is, where you can find me. And here are a couple of links for you. And worry not, if you would like to find the same thing, it's, at my website, so laugh.pl. You will find this there. Now, without further ado, let's jump into the annotation, because honestly, we don't have much time. Now, a simple example, and I'm hoping you can see this. Just in case, I'll increase the font a little bit, It's already, in the presentation mode, but let's go. So what I actually have here, I have an interface with the @ sign, right? The @ sign is actually very, very important. Annotations began as, something that Xdoclet got going, and also there was one more project on the EJP side. Now, they both actually use the @ sign, and hence the @ sign made it into annotation. So annotations are frequently referred to as metadata or metaprogramming, because they allow you to, write the data about your data, or use the program to, program your program, as in generate the sources, for instance. Now, what I would like you to know is that we actually began this with simple interfaces. So serializable, clonable. They are interfaces which have no methods inside. They are empty interfaces. Why would we ever do that? Why would we need that? Because those interfaces were marker interfaces. They got us some details, like they allowed us to know that you can serialize that, you can clone that. Now, that was nice, but we decided that we can do better. And in Java 5, we introduced the annotation. If you would like to begin, totally begin, then I have a few things for you. First of all, the annotation itself. The annotation is the common interface. Now, if you just implement this interface, it doesn't make your class that implements it an annotation. But this is the interface that pretty much every annotated element will, find its way upwards to. Now, interestingly enough, if you'd like to know how does it work, then here you have an excellent overview. How are, things processed? And I can actually just launch it like here. Now, the other thing that I would like to give you as real beginners is the third link, the Java as a trail for annotation basics. So if something I will say with regards to the basic will be unclear, follow the third link over here, and it will actually help. Right, so annotation allows us to, annotate an element. I'll get into what and when in just a minute. This means that we can actually get a meaning on an element. We can say this element is important for some reason. Annotation will tell you why. We can actually mark this element as I want to measure the time for this element to be rendered or executed or something else. We can actually use annotation to generate sources, like when you enter the method, do this. When you exit the method, do that. So there are plenty of different ways we can use the annotation, but generally, they boil down to the following. One, you signify something. The annotation carries certain intent. Your intent is made clearer because you have annotated something, a class, an interface, a method, a field. Now, the other thing is related with sources, like how you, or the tools that you use, like compiler, Maven, other things, how they actually touch the sources. Yet another thing may have to do with if you see this annotation when the program runs, do something. If you see this annotation in the compiled code, do something. All right, so we can actually offer metadata, we can metaprogram, we can signal some intent, carry some, well, data around. Okay, I think for a simple example, that's enough. Let's take a look. What can be targeted by an annotation? So here we have a very simple interface, all right? It pretty much does nothing. There is nothing inside, so we can say this is an empty interface, but the add makes it an annotation. Now, I'm having here a piece of commented code, bear with me, and let's take a look. I can put it on a class, I can put it on a field, on a method, I can put it even on a method parameter, or on a local variable. Furthermore, I can put it on an interface, method in an interface parameter there. I can actually also put it on a record, parameter for the constructor for the record, and also the method and the parameter inside it. Now, enum, absolutely, enum constants yet as well, and the annotation, because notice this is not just interface, this is annotation, also can be targeted by, well, target. So what does it give us? Well, let's say that I'll actually, narrow this down. You don't need to have the target annotation on your annotation. You can actually do not specify. If you won't specify it, as you can see, it works incredibly broadly. Pretty much the only thing that doesn't work here would be generics. So here, I can't put it because, well, I would have to use type use or type param. And similarly here, with same reason. So if I actually go right now and make it a local variable, of course, I'll need to Alt enter a few things. And now almost everything is highlighted because, well, if it isn't a local variable, then I'm using it wrong. So right now I've narrowed my annotation to just, the local variable. So pretty much the only place where I can use it is line 23. Well, all right. So let's take a look at what we have here, what is being offered. And as you guys can see, there is plenty to use. Now, of course, not all will be displayed here. We only have like 45 minutes, even less right now. So without further dilly-dallying, let me briefly walk you through what we have. Type is record, enum, class, interface, annotation. Annotation type is the annotation, method is self-explanatory, local variable you've seen demonstrated, field for things which you have in the classes, and constructor if you're willing. Spring uses that a lot through dependency injection. Module, if you're using Java 9 modules, you can actually annotate a module, in which case you will be actually having, well, pretty much everything in the module following to that. Package allows you to document the package, for instance. We will be showing that in a moment. Parameter for a method, record component, and type parameter type use are helpful when dealing with generics. Let's see. And sorry. Unfortunately, my ID got lost, and it will take it a moment. Well, experiment it with your own time, and here I'm commenting it out, moving along. The retained information has actually much less levels. For the target, one more very important thing I should have shown you. For the target, one very important thing, if you wish to really deeply understand it. Now, over here, you have some examples, but the interesting part about that should be the C. Now, if we go into element, we have here the information where, how, and what. And on the Java doc, but I think it wasn't this version, it was an older version, there were JLS links, which I'll include in the documentation. Well then, I seem to have missed it. All right, we'll have to take a look at it a little bit later. So, the JLS links will tell you what the target actually means. Why? Because there are some gotchas, like the parameter type. It wasn't, so simple to follow, and you may actually want to look into what does it mean to put an annotation in a package, because, well, it may not work as you think it does. Now, the interesting part here, next one, is when it is retained. So allow me to break the code a little bit. And what we're having here, we're having first 3 annotations. One has the retention set to source. The other has the default one. The default is for the class. And the third is for the runtime. Now, those of you who actually know a little bit about compilation, you already probably have seen the pattern. Something that is on the source, when we compile, it will be discarded. Something that is on the class, when we run, it will be discarded. So the only annotation that will be remaining when we run the application is the runtime one. So retention policy tells you when do you retain your annotation. And what I'm having here is I'm having 4 print lines. Those print lines are actually taking, the class, and they are asking, hey, I want to get the declared annotations and then by type for the source, class, and runtime. So this is a fairly simple code. Now, if I run it, you will see that when I'm running the code and I'm asking, hey, how are you annotated? Hey, a class, are you annotated with this or that annotation? You will see that, well, the only thing that I can get is the thing that has the runtime policy for the retention. However, if I would like, for instance, to take a look at this and say, take a look at the bytecode. Oh, I need to compile it, but I should have compiled it here. When it is retained, right. And take a look, fellas, that in my bytecode, well, this is pretty much the main, but the interesting thing is, let me do a search here. All right, so I have the classes mentioned, yeah, and I'm asking for them. So this is the code that asks for a class and tries to print it, but the runtime and the class, they happen to be here, but the source, it disappeared. No? So my classes, during the compilation, the class for the source only annotation already was, kicked away because we don't need it, to be honest. That's not something we want. All right. Now, these were the basics. Let's talk about the built-ins. Now, in the built-ins, there are several interesting things. Let's talk about functional interface and override. There are plenty of more, and, well, among some, deprecated, documented, inherited, native, override, etc., etc. Now, let's start with something that is the basic use of the annotation. You're annotating with sometimes source, sometimes compilation to pretty much take a look at your code. Sorry. So when you're annotating to take a look at your code on the source level, so retention policy, source, target, I don't care, think about your own example. What actually happens here is the compilation will take a look at it, react during the compile phase, and, do whatever is necessary. The first example, I have here a functional interface. The rules for the functional interface make that it may have only one static abstract method, not 2, not 3. What doesn't count? Statics, single abstract method. Static don't count, default do not count, and of course, things, which we get from the object also do not count. So these 3 methods, they don't count. And with this, the functional interface annotation makes the compiler check, is it a functional interface? If the check is broken, we get the info. So let me uncomment that, and you see the functional interface complains that, well, this is no longer a functional interface. What are you doing, dear user? Now, the other thing, we can have, a record where we could actually use override, and, we could actually do something like this and think, oh yeah, we are overriding toString, where we are not, because toString never accepts parameters, so that's a mistake on our part. Sometimes to use the override will actually help you with quickly understanding, is it really overridden from the something above, interface, class, whatever else, or do we only think like that? Now, these are interesting annotations, so let's take a look at one thing here. Now, the override being put on method, that makes sense. The override having the source policy, that makes sense. Now, interestingly enough, if I take a look at the override, you will see that target and retention are actually part of the Java doc. Why do you think that is? Well, because if I do this, I can take a look that here I have a documented. So documented annotation pretty much tells you annotations that are put on this element will be part of the contract. Right, so back to what warns during the compilation. Let's take a look at the functional interface. Yeah, we could expect that, wait, runtime? Why would it be runtime? I mean, I get the type would be the element. We are pretty much creating something that will later be used to, create an anonymous class with a lambda inside dynamically, of course. But why would we have the retention policy runtime? Why not source? Why not something that, the compiler will take a look? Well, because of local variable and because of, well, type inference. So if you want to get more into that, I would suggest to look there. Now, sometimes you want to have your annotation to be on the runtime level because, for example, you will have other code that will interact with it and tell you that something is wrong, that you, for example, are not doing this functional interface properly. For instance, one of the things you could do was to check if there is already an existing functional interface that you could use instead of, your own that you just created. Okay. I think that's enough about the basics. Oh, wait, the built-ins, one more thing is helpful here. So, fellas, suppress warnings. Now, what I'm having here is I'm having suppress warnings. I would like to tell you a few things about that built-in annotation because I frequently see that people are not aware of that. So I have here a static list which is cast totally without sense. It shouldn't be cast at all. So line 17 has a cast that is unused. The array list is initialized statically by, adding something, but the types, the generic types, they're not there. So I'm actually operating on row types. I'm using an extra cast, which is not needed. And I'm also having an unchecked operation, like, can I, do something with the int in this list? What if somewhere else I'm using a string? I'm not, but that's beside the point. Now, my main also has the unchecked empty row, and also it has one more warning with the linked lists, assignment. Now, if I want to make everything disappear, then I can say actually all. Please don't do that. No, please really don't do that. But what I wanted to show you is that if, for example, I will, do row types here, then I can delete the row types from this because it's actually an array. We are seeing here how annotations are taking attributes. So the suppress warnings attribute has, first of all, a lot of possible targets. You can, put it in lots of places. And it also has a value. The default attribute will always be named a value. If it's named a value, something that is really important, I don't need to write the name over here. So I can do value equals. And this is all right, but I don't need to because value is the default one. So if your annotation has one parameter, name it a value and be done with it. Now, here I'm having a row types, but here I'm having a row. In some cases, this will be, identical, but in some cases it will not. If you write here, I don't know, something really strange like świdrowiatrak. By the way, if you're actually thinking, what the hell is a świdrowiatrak? This is a świdrowiatrak. Now, let's say that you wrote something totally strange and Java definitely doesn't have świdrowiatrak inside. So what can you do? What will happen? Nothing. Compiler will just ignore. Unfortunately, you may not get it unless you actually, trigger a warning. So if you're using suppress warnings, then I would strongly advise that you also allow your compiler to output warnings and you would periodically look at those warnings because perhaps you're not suppressing what you think you're suppressing. And final thing about the suppress warning annotation is the fact that, with the rotate over here, it's pretty much on everything. But the general consensus is don't put it on the overlooking element, the encompassing, all-encompassing. Do it directly on the element where it's needed, because, well, that's better this way. All right. Let's move to tests, right? So a very simple case. I have tests. I would like to run the tests. Did you ever wonder how this actually works? Why do we actually use it? How do we use it? What is, let's unpack this reflection API, the dark magic. No magic, actually. So I have a method annotated with a test. I have another, and I have the third. It's pretty much identical, except it's not annotated. So I'm having my class, and what I'm doing is, of course, I'm having this test annotation. So because I will be running some code that will take a look at my code, then I need the test annotation to stick around until I get to run anything. So the retention policy must be runtime. Now, I'm, of course, interested in test cases which are methods. So element type is narrowed down to methods, because why the hell would I want anything else at this point? Of course, so the annotation is fairly simple. And now what I'm doing here is I'm having a very simple piece of code. This code takes the class that I'm interested in, right? On it, it gets the declared methods, which returns an array. I'm streaming that array then. And once that happens, I'm filtering for things where the annotation is present, which run the test, of course. Now, for each method which I'm then having, so method with the test annotation, I am actually invoking my method. Now, to invoke my method, I, of course, need the instance to invoke on. All right, so that's fairly simple. Let's run it. And I've run a foo and a boo, which were, if you don't remember, here and here. The go was never run. Now, of course, let me put a test on go, because I decided, no, it's a test after all, and let me rerun the code. And we will quickly see that foo and boo are still there. All right, the go joined the predecessors. All right, cool, this works. Now, if this works, how about ignoring the tests? Now, ignoring is, well, fairly simple. Let's take a look. I have a test which I'm deemed worthy of ignoring. To be honest, don't ask me why, because I would be hard-pressed to give you the exact reason, because foo and boo are pretty much identical. But let's say I had a reason. I usually also don't, but let's not go there right now. So I have the ignore annotation. Retention policy is runtime, and I'm also saying element type method, but I decided that I will want that on the Java doc for reasons, because, well, letting know that this is ignored is actually seems like a good thing. Some test frameworks will actually do that with the ignore annotation. So, all right, back to the first test. Let's take a look at the second test. The second test has slightly different ignore approach. Now, that's usually how the testng is doing that, and the previous one is how the JUnit is doing that. And pretty much between the two, all the other test frameworks are choosing one of the two approaches. So here I'm having an attribute. Now, interesting thing about the attribute that actually attributes are methods. So I'm saying that this will be Boolean, it will be ignore, and the default value is false. So here you go, and yet another use of the keyword default, which you may now, post about to all your colleagues, and of course, definitely to your parents. They will be very interested. Now, my test annotation is clear. Let's take a look at my test runner. Well, something more happens here. I have two test runners, and I did some, small refactoring. So, is a test method is pretty much as we had it previously. So, is the annotation present? Yes or no? That's it. Now, I also have is not ignored. So is not ignored test method pretty much asks about the ignore annotation, but is not ignored asks about the attribute. So what I need to do, I have my annotation, which I'm getting by asking for annotation of specific kind. Now, interesting thing about this method if you ask a method, hey, do you have a test annotation? And it didn't, this returns null. So what I'm doing here is I'm saying, okay, if it had null, so yeah, I don't care. And if it was ignored, then okay, cool. So with this, I can actually have both ways. So I'm running my first test class with the isIgnoredTest method, and I'm running the second with isNotIgnored, so on the attribute or slash method actually. Let's take a look at that. And I'm having a bool and a buzz. So let's take a look if that's actually correct. So the bool is ignored and the foo is not. And the go was, well, not even in the running. Now, second test, I'm having the bar and I'm having the buzz. So I did a bad thing in, well, conditions. And therefore, I picked up the ignored method because I filtered for what had the ignore instead of negating this, all right? So here, let's take a look at the time. Oh, wow. We'll have to speed things up. So I'll leave the correction for later because I have more to show and I need to get there. So what I'm having here is, well, something we want to change something. And this is like this is pretty much the key part of the presentation. So please pay attention. First of all, running things manually is absolutely mind-numbing. It's soul-crushing. You don't want to do that. So if you ever find yourself doing something like this, please don't. This is the approach that JUnit took with, test suits. And you were pretty much forced to add a new test to a suit, and that way you had the grouping of sorts and the running also. But no, that's not really a good way. If you're finding yourself doing that, I would actually, tell you, hey, make a bash script, grep for, the annotation in your code and add your files, directly like this, and then read the file and for each, class, do the class for name, etc., etc. This is doable, a bit tedious, somewhat bashy Java or Python-y Java. The bridge needs to be there, but yeah, you can do this. But you can do something else. I'll run this, of course, manually, just so that you will see that it actually works. What this does is it takes a class, and for a class, it executes the run, and all the tests are there. Cool. But I could do something more interesting. This is how Spring does it. And yeah, it's reflections. It started with this Annotation library, which was much less performant, and it had few not so great architecture decisions made. So the reflections people decided, in the spirit of Annotations, let's do a library which scans the class path. What does it mean to scan the class path? Well, class path is the location where Java is looking for your classes. When you're saying, okay, I want to use hash map, it looks on the class path. When you say, I want to use reflections, it looks on the class path, etc., etc. So this is a simplification here. Bear with me, sorry for simplifying it that much. But what you're doing here is you're saying, okay, I want you to scan for all the annotations within this package. And you have two ways. One, you can just say, I'm interested, once the reflections is full. Reflections is sort of your database, and here you're querying it. You have two ways of querying it, main ways. One, you're saying, I'm looking for things which, subclass this. And the other thing you could do that is, I'm looking for things annotated with this. So what I'm doing here is I'm saying, all right, I'm looking for things to run the test. You can see that the run test is pretty much similar, I'm passing all the methods and I'm passing the instance of the, thing to invoker. So what happens here is I'm saying, okay, give me all the types annotated with the test class. For each such type, what I'm doing is I'm getting the methods and then I'm getting the constructor, and the constructor and calling new instance. And voila, that gets passed to the method. Let's take a look. Control-Shift F10. Now, the problem with this solution is that it means that the entire class path needs to be scanned. Now, for a small project such as this one, this isn't really a very large concern. But if you're running an incredibly large thing, then, well, darn, it sucks to be you, because classpath scanning needs to take a look at everything that is on the classpath. So if you actually extended your classpath with some library directory, and there are the libraries that you use as a dependency, they will be scanned. If you have a zip file on the classpath, it will be picked up, unpacked, and the contents will be scanned. If in the zip you have a jar, it will be unpacked and it will be scanned. Every single jar is pretty much an archive, so you need to unpack it, so decompress it. And yeah, honestly, I do believe that there is a better solution. And this is a Polish aspect here for this presentation, because there is a very nice Polish library by, I think, people from Toruń. And what they did, they actually discovered that, yeah, it's a very simple thing. If I'm scanning the classpath, then I'm having the complexity ON, where N is, well, the classpath length. But I am scanning the classpath when I'm actually loading the classes, because I need to load the classes. I need to have the classes in the memory. That's how compiler, well, running the application works. I'm taking all the .class files which are needed, and I'm, instantiating them, initializing them. I'm putting the statics where the static belong, the non-static on the heap, etc., etc. Now, all of that is being done already. So why do I need to repeat the process? Why don't I just, plug into that process? And here comes the indexing of the class path. And this is done by the class index library. So the class index library decides, okay, let's get the annotated test class. But first, for this to work, I need to do something more. I need to decide and mark that anything that is marked with the test will be, of course, something for me to index. The second change is, now I'm not only putting the test on the method, I'm also putting it on the class. Now, the interesting thing about that is this makes the test appear here on the class, and it makes it appear here on the other class. So my test methods are showing in both cases. Now, the test annotation is marked with something from class index, as you guys can see right now. And this means that when I'm loading the classes, I'm trying to actually construct the list of files which are being indexed and marked with the add test. All right. So this brings us to having a simple piece of code. For each class, I'm actually, getting the declared methods, getting the constructor to get the new instance. I'm passing this to my run test for all methods object to invoke on, and I'm doing, the invocation. This code could be made simpler. Let's not beat around the bush. This code could be made simpler. It should have several tests. It should be, more encapsulated. Actually, when you do things like that, you'll notice that people very often end up creating their own helpers. In one of the classes, there is a very nice link, like to reflection util helper, which is done for the testng library. And if you would like to take a look at the, in-depth life of the test lifecycle, how you can, plug in using reflection, how you can actually, change the reporting output, do other various things, I totally recommend you testng as a quite powerful library in that regard. Well, all right, this means that we have, some time left. And with this, we are left with how to do a package level annotation. Element type package, that's one. Package annotation, just to show you that it's there. And how do I do this? Well, I'm creating a package info. Package info is not a Java class. Package info is actually just a file with the extension Java, which can hold the documentation for the package. One of the best packages that use it is Java util concurrent. So take a look at that and you will find, well, how much you can cram in the package info file and how great of a documentation this can make. And here I can actually annotate my annotation, which may later be processed, or it may be, discarded at the source level. Perhaps I'm having a program which just scans the sources, and when it sees it, then something happens. Or perhaps I have created a dedicated annotation processor, which I made available to my compiler and told him, hey, compiler, when you do a compilation, remember, here is an annotation processor I made, and it is just especially for a package level annotation, just to show you how this is supposed to be done. All right. I think we can move on to Lombok. One of the very interesting things about Lombok is that it gives you plenty of annotations which generate code for you. So this is the example where stepping into territory where having an annotation generates code for you. Now, the most iconic, I would say, because my criteria is very simple, because JDK decided, yeah, that's interesting enough, we are pulling this into the language, that would be the value. So the value gives you, you know, a class with just fields, and it gives you number of things for those fields. So what you're getting is equals, you're getting hash code, you're getting toString, you're getting, I think, constructor, but, you know, don't rely on me, check the documentation for the Lombok. And of course, you're also getting getters, but you're not getting setters, because one of the interesting things is the end result is by default final and, you know, immutable. So very good for example, multi-threading. Now this is generated. So during your code compilation, this source needs to be generated. And for your IDE to be aware that you have all those methods, you need to attach the annotation processor for the IDE. So one of the interesting things is that Lombok has the installation procedures as well. That's the first, but if you go annotation processor, you need it. All right, so here I'm having pretty much the same, but using the record, the new thing in Java 14. And the difference is, well, pretty small with the main case, but pretty large when we decide to go, you know, with some specific cases. So what I'm having here is I'm having violinists, and I'm having violinists which are done, you know, using the record, and I'm having them two. There is Henryk Winiarski and Hilary Hahn, and one is no longer among the living, the other absolutely is among the living, terrific violinist, by the way. And I'm also creating the same, pretty much almost the same thing using Lombok, all right? So you have seen the code for both the Lombok and non-Lombok version. What you're having here is some printouts which can confirm how things look. So let me, you know, get to the full screen, and you can see that, well, the printouts are actually identical. So the way the toString is generated is, well, identical. Now, the other thing that you're having here is the key value notation, and you also have the comparisons. You can see that equals work, that the hash code work, and that the toString work. You have the constructor, because I use the constructor, for example, in line 18, 19, or in line 14 or 16, and therefore, pretty much everything is done. This is great to have, you know, a value object, one of the DDD building blocks. All right, so what is the difference, you know, if I want to have that? Should I choose record or should I choose Lombok? Now, if you have the very basic thing, like just the mainstream, you want to have a simple class with toString, hash code, equal, private final fields. The class should be final, and the constructor should be all args constructor. Then I would say go for the record. Why? Because it's built into Java, and you don't need any special setup. And bringing new features is actually nice. When you should go for Lombok is when you want something special. For instance, if you want to go with private no args constructor in the record, might be problematic, you know, if you want to, if you are after, okay, I want actually to create contemporary violinist. I don't like the fact that I have, you know, the Boolean variable there. So if that's the case, then unfortunately you learn that this is a final class and there's that. But Lombok has the non-final annotation which you can use, and it also has other configuration knobs which you can, you know, try to turn to whatever you need. So greater flexibility is definitely in Lombok. Nikolai Parlok made a really great blog post, very in-depth. So if you want to look more about Lombok versus records, go there. All right, I think that's mostly done. We should jump into a huge-ass topic, which is annotation processing, which we in no way will manage to do today, even if we actually started from this very topic, you know, and I was supposed to start from the beginning. So allow me to do something simple. And right now you're probably seeing just the terminal, but give me like one moment. I'm actually jumping right now to a different project. And in a moment, IDE should be, back on screen with a new project. And in the meantime, right now you guys should probably see darn it. Okay, so this is loading. It will take a moment. What we're getting with annotation processing? Well, we need two projects. One project, which is the client project, which will use the annotation processing infrastructure, and the other is the annotation processor along with the infrastructure. So what I'm doing over here is I'm having actually, a fairly large, come on. All right, this should be large enough, but just in case, let me increase font a little bit. Oh, it scans things in the background, so it's not so fast as I would want to. So what you're seeing here is a very, very simple abstract processor. The source for that is a very excellent blog, which has a 3-part detailed dive into creation of the annotation processes. I totally recommend you to set aside 3 hours for each and every part. What you have over here is, first thing first, which annotations you are working on. Annotation processors need to have the annotation they support, and well, that's a serious limit. The second part is, if you will be generating sources, you need to actually decide which version of Java those sources will work in. And there are plenty of those, like from 0 to 17 or even 18. Yeah, 18 is not yet here, not in my Java version at least. Now, what I'm having here is some processor which, and this is again very important, extends the abstract processor. Now, the abstract processing gives me one method which gives me a boolean. This is like, did I process the annotation or not? And I'm getting number of annotations and the environment in which my processor will work. These two are like, this is pretty much a heavy hitter, because with the environment, you get, for example, things like, like diagnostic tools, or error handling, or verifying the element types, etc., etc. So you would usually, as I said, this is a very, very simple, but usually you would start here with making sure that your annotation is there, that the set of annotations that you got isn't empty. Then you would start checking if your annotations are of the element you wanted, and if they are on the element you wanted. So for example, it is a test annotation and it is on a method, and this method doesn't have ignore, etc., etc. And you would do things then. What we are doing here is we are pretty much saying, all right, let's print a message. And this message is a note. That's interesting because you get the entire, kind of hierarchy and enumeration, which tells you what kind of messages you're supposed to print where. And then we're returning, yeah, process the annotation. Now, interestingly, let's take a look at how it works. NVM clean install. Oh, wait, that's here. Oh, simpler. The alias will do. And what happens is you will see this message done and outputted by the annotation processor. So let's take a look at what we're getting, because I showed you the annotation processor. This is the log annotation, which is very, very simple. But what is actually interesting is the project which has the thing, yeah? We have the hello, and it actually has the log annotation on it. And over here, you have the message. Well then, I'm 2 minutes after, so While I would like to tell you more and demystify the annotations more, I'll have to leave it for the next time or for another opportunity. And with that, I'm passing the voice back to the studio. Thank you very much for your time and see you next time.